Cosmic headlines. A universe of wonders awaits. Breaking news from the cosmos. Strange signals detected from a nearby star system. Is anyone out there? Scientists are racing to decipher the message. A new Earth-sized planet has been confirmed in the habitable zone of a sun-like star. Could it harbor life? These headlines keep us looking up, reminding us we're part of something vast and unknown. Imagine yourself in the cockpit of the fastest ship ever conceived, accelerating to a fraction of the speed of light. Earth shrinks behind you, a blue marble in a sea of black. Your mission journey through our local cosmic neighborhood to witness firsthand the wonders our telescopes only glimpse. The universe is calling, and we're finally getting ready to answer. The journey ahead is perilous: micrometeoroids, radiation, and the crushing emptiness between the stars. Yet, the rewards are immeasurable: triple sunsets, glowing nebulae, the birth of new stars. Our voyage begins now, as we leave our home system behind and venture into the star-dusted expanse of the Milky Way. This is more than a sightseeing tour. It's a quest for knowledge, a search for our place in the universe. Every star we pass, every planet we scan, brings us closer to answering profound questions. Are we alone? What forms might life take? So buckle up. The greatest adventure in human history is about to begin. The universe is vast, and our time is short. Let's get moving.
Before we dive into our journey, let's appreciate the scale of our home galaxy, the Milky Way, that faint milky band in the night sky. It's the combined light of billions of stars in our spiral galaxy. The Milky Way is a sprawling city of stars, 100 to 400 billion of them. For every person who's ever lived, there are dozens of stars in our galaxy alone. We live in the Orion Arm, a quiet, suburban neighborhood, ideal for life to develop. The galaxy is about 100,000 light-years across. Even at light speed, it would take 100,000 years to cross. Our sun orbits the galactic center at 230 kilometers per second, taking 230 million years for one lap, a galactic year. The last time we were here, dinosaurs were just beginning to roam Earth. The interstellar medium, vast clouds of gas and dust, fills the space between stars, birthing new stars and planets. Beautiful nebulae like the Orion and Eagle Nebula are stellar nurseries. The galaxy is also filled with mysterious dark matter, making up 85% of the universe's matter. The Milky Way is our home, filled with wonders and mysteries beyond imagination. Let's explore it together. Our journey begins at Alpha Centauri, just 437 light-years away, our next-door neighbor. Up close, it's a spectacular triple-star system: Alpha Centauri A and B, a tight binary pair, and Proxima Centauri, a distant red dwarf. Alpha Centauri A is a G-type star, much like our Sun, but slightly larger and brighter. Its similarity makes it a prime candidate in the search for Earth-like planets. Imagine a world with two suns, alien sunsets, new ecosystems, endless possibilities. Alpha Centauri B, a smaller, cooler, K-type star, orbits its companion, creating complex gravitational dynamics. Proxima Centauri, the third member, is a tiny, faint red dwarf, currently the closest known star to our Sun. For a long time, astronomers weren't sure if Proxima was even bound to the other two. Despite its small size, Proxima holds some of the biggest secrets in our cosmic neighborhood. The Alpha Centauri system is a tantalizing target for exploration. Let's see what secrets it holds. As we approach Proxima Centauri, we enter a region of intense scientific interest. This dim red dwarf hosts at least 2, possibly 3, exoplanets, the closest planetary system to our own. Proxima Centauri B, discovered in 2016, is Earth-sized and orbits in the habitable zone. But its close orbit likely means one side faces perpetual day, the other eternal night. Red dwarfs like Proxima are volatile, unleashing powerful flares that could threaten any potential life. Proxima Centauri C, a super-Earth, orbits farther out, cold and icy, with a year lasting over 5 Earth years. There are hints of a third, even smaller planet, Proxima Centauri D. The Proxima system is a natural laboratory for studying planetary formation and the potential for life around red dwarfs. As we cruise past, we wonder, what secrets do these worlds hold? The search for life continues. Even with our imaginary supership, the tyranny of distance is clear. Alpha Centauri is still fantastically far. With current rockets, a journey there would take tens of thousands of years. Enter Breakthrough Starshot, a revolutionary project to send tiny, gram-scale nanocrafts to the stars. Each nanocraft, equipped with cameras and sensors, would ride a light sail pushed by a powerful Earth-based laser. The goal reached 20% the speed of light, making the journey in just over 20 years. The challenges are immense. Building a massive laser, creating ultra-thin sails, miniaturizing electronics, and aiming precisely across trillions of miles. But these are engineering problems, not fundamental physics. With enough ingenuity, they can be solved. Starshot could bring the stars within our reach. The dream of interstellar exploration is closer than ever. The future is being built now. Leaving Alpha Centauri, we head to Barnard's Star, 6 light-years away, a red dwarf famous for its rapid motion across our sky. For decades, astronomers searched for planets here. Recent evidence hints at a cold super-Earth. Barnard's Star B, though its existence is still debated. The saga of Barnard's Star is a perfect example of science in action. Claims, refutations, and new discoveries. Next, we visit Sirius, the brightest star in our night sky, just 8.6 light-years away. Sirius A is a massive blue-white star twice the mass and 25 times the luminosity of our Sun. Orbiting it is Sirius B, a tiny dense white dwarf, the first ever discovered. A teaspoon of Sirius B would weigh several tons. This glimpse into stellar evolution shows our Sun's distant future, a faint, cooling ember. The stars around us are diverse, some young, some ancient, some paired in dramatic duos. Each has a story to tell. Our journey through the neighborhood continues. The cosmos is alive with wonders. Next, we visit Wolf 1061, a red dwarf 14 light-years away, one of the most promising systems in the search for life. Red dwarfs are the most common stars in the Milky Way, making up 75% of the population. Wolf 1061 is unusually quiet and stable, lacking the violent flares of stars like Proxima. It hosts at least 3 planets. The middle one, Wolf 1061c, is a super-Earth in the habitable zone. With 4 times Earth's mass and a thicker atmosphere, it could regulate temperature and shield life from radiation. Its year is just 18 days long, and the sky would glow with a dim reddish sun. Is there life there? Oceans reflecting crimson light. Alien biology adapted to a red dwarf world. Wolf 1061c is a prime target for future telescopes like James Webb. The search for habitable worlds is just beginning. The universe may be teeming with possibilities. As we travel between stars, we're not in a perfect vacuum. The interstellar medium, a thin mix of gas and dust, fills the space between stars. Our solar system is currently passing through the local interstellar cloud, or local fluff, a warm, wispy cloud about 30 light-years across. Despite its 6,000 degrees C temperature, it's so diffuse that it poses no threat to our ship. The Sun's magnetic field creates the heliosphere, a protective bubble shielding us from harsh cosmic rays. The interaction between the solar wind and the local fluff forms a complex boundary, like a boat's wake in water. Instruments on spacecraft have detected interstellar atoms entering our solar system, giving us direct samples of star-forming material. We are travelers through a cosmic sea, intimately connected to the galaxy around us. For our final stop, we visit AP Columbi, a star just 40 million years old, an infant compared to our 4.6 billion-year-old Sun. Unlike most young stars, AP Columbi isn't in a stellar nursery. It's a runaway, flung from its birthplace by a dramatic event. Perhaps a close encounter, or a supernova sent it speeding through the galaxy, a cosmic orphan among older stars. By tracing its path, astronomers linked it to the IC 2391 supercluster, now far away. AP Columbi's journey is a testament to the dynamic, sometimes violent nature of the cosmos. Every star has a story, some of stability, some of drama, some of exile. Our brief journey has only scratched the surface, revealing a universe more active and fascinating than we imagined. The galaxy is a collection of histories written in the stars. All we have to do is look up and read it. The story continues, out there, waiting for us.